Hi everyone, welcome back to Learn Pega by Practice. So I'm actually created this is another problem which is an extension of problem 1. Before you go through this problem 1.1, so I would recommend you to go through the problem 1 video, which is creating an interactive UI within Pega. So this is an extension of problem 1 where I would be explaining you in problem 1. So whenever user selects the documents and starts the processing of the document, so the users can actually see each document which is getting processed and completed and so on. But all the document processing of when the user select multiple documents, the documents are processed in sequence, that is one after another. Okay, so I've explained you guys that as part of the previous video, assuming that the document is processed by calling a service where we pass the document ID, assuming that it would take, let's say it takes an average 3 to 5 seconds, between 3 to 5 seconds and average 4 seconds, right? So if at all, if we are processing the documents one after another, uh, if you say that there are 10 documents on average, it would take 4 seconds to process it, right? Then the user has to wait for 40 seconds to complete all the document processing, right? So although the UI is interactive, users would know which document is getting processed and what is the outcome of the processing and so on. The user has to wait for a long time to, wait a long time to wait for all the documents to be processed. So is there any way to the problem 1.1 is extension of which instead of processing it in sequential, can we process it in in parallel, that by taking the advantage of the uh, parallelism which is available within Pega, right? So there are two options. So I'll be explaining those two options. But at this point of time, I strongly recommend you guys to download the solution problem for problem 1 and try to enhance the UI to process the document in parallel, so you can read through some of the concepts which is available within Pega and try to implement on your own. So anything which is implemented on your own, you would learn a lot. Okay, so I would strongly recommend stop this video, go try it on your own to process the documents. If you are not able to, then you can come back to this video and see the solutions. Okay, so going to the solutions, there are two solutions to this. Instead of processing it sequentially, can it be done parallelly? So there's a single node solution and multi-node solution. In single node solution, what we do is, when the user clicks on the bulk process documents in bulk button, so an activity is executed, and in the activity we check if that particular document is selected for processing or not. If yes, then we call a data page in by using load data page method, where we pass the document ID as parameter, and that data page would call the external service by using the connector. Okay, so in this scenario, what we would use the running multiple data pages in parallel by using load data page method, which is available within the activity. And once after running all the data pages in parallel, so you can give, whenever you are running a particular load data page in activity, you can give an option, you can mention what's the pool ID, and you can wait for the completion of all the data pages within that pool. And once it is once it is completed, you can check for the status and then refresh your UI. That's the single node solution. So let me log in and then show you. So if at all, if you are not aware of that load data page method, so I can quickly show you what is available. So for the people who are not aware of problem 1, so I'll just remove the solution. So I'll show you what has been achieved to problem 1. What is the problem 1? How does it the demo of problem one solution. So if I select 4 documents and then process them, if you see that each document gets processed one after another in sequential. So there is no parallel method, so it gets processed one after another. The advantage here is it clearly shows which document is getting processed, and it will, once these, based on the outcome, it will show you the success or failure, right? This is the problem one. So just for the people who are not aware, so let's go back to, let's create the test branch, as the test branch is already there. So just to explain you the load data page in async. So okay, so as I'll not be covering the solution one, which is single node. It's just very straightforward. You can try it on your own. So it's not very very complex. You can just try it on your own. So I'll be explaining the solution which is implemented using multi-node. So I'll, which I'll be explaining after this. Okay, single node activity. So there's an option called load data page. So when you load data page, you can actually give the pool ID and the data page name, and you can pass the parameters to the data page. So let's say if you loop, and for each of the document you can call the data page by passing the document ID as parameter, and the loop pool ID will be same for all the entire loop. At the end you can just use connect wait method, connect wait connect wait method, which is you will wait for certain seconds to by passing the pool ID. So you would, whatever pool ID you give here, let's say if you give 10 or 121, you would give the same pool ID here, and you would wait for certain time to complete all the documents. And once all the document processing is completed, you would come out and update, refresh your section. Okay, so this solution is something which you can try it on your own. So I will be explaining you the solution, second part of the solution, which is multi-node, taking the advantage of multiple nodes. So here the browser, right? When our user selects the documents and clicks on submit, all the documents which are selected. So whatever documents are selected, it would be sent to your server. The server would loop through that list of documents. It would actually check if any of the document is selected for processing. If yes, then it would queue it for queue processor. Okay, so queue processor is an advanced version of your agent, queuing it for an agent. Okay, instead of queuing it for an agent, queue processor, in agent there is always a delay of 30 seconds, right? Whenever a queue keeps running and checks if there is any queue item which is waiting to be pulled, so there is a delay. But in queue processor you can configure it to run it immediately without any delay. Okay, so but yeah, I'll not be covering the advanced concepts of queue processor, but I'll give you a basic idea. So one, you will queue that for queue processor. This queue processor will be configured to run on multiple nodes. So each item would get either by one of these nodes, and based on the configuration of your queue processor on how many threads to run in each node, you can you can um, so each node can run multiple items based on the number of threads which is allowed. So each thread would again then pick up the queue item, then call the external service, which is same as the single node solution. To call the service by passing the document ID, and then once once it is successful, right? So the status is pushed back here to browser. Okay, so in single node, what happens is the call from your browser to the activity, and then outcome once the activity is completed is in sequence. But however, your data pages are loaded in async mode. But in case of multi-node solution, so there is no there is no once the request is sent from your browser to server, there is no this connection is once this once your request is sent to the server, it is done. So how would the server then send back the status back to your browser so that the user knows what is the outcome of that processing, right? So for this, we would use the concept of push notification within Pega, which is not nothing but the web socket concept. So where you would there is a message pushed from your server back to your browser, and the browser would be waiting for such kind of notifications. Once you get it, you would perform an action. For example, let's consider refreshing a section, so it would refresh your section and so on. So the advantage of multi-node is the multi-node solution is we would run multiple threads on. The more number of nodes you have, you have you can actually process more number of documents in parallel. Okay, so if at all, if you have like say 3 or 4 nodes, you can and 3 threads in each of them at single time, you can process 9 documents in parallel. So that's the advantage, and the load is equally distributed among the nodes, and that's the concept of the cluster, right? So in that way, you can achieve more throughput in multi-node. Okay, and so I'll be explaining you the coding part of it now. So let's go back to the application. So now the solution for this particular problem is also available as part of the description of this video, which is uploaded in the YouTube. So you would find out the problem statement as well as the solution diagrams, the base application, and the solution branch. Okay, so let me open the solution branch. Just add it to the application problem. So the branch name is problem 1.1. So let me show you the quick demo. So if you see here, I just selecting two, and the reason being there are 2 threads which is configured on your queue process to run in parallel. So you would see that both of them would run in parallel and then get updated together. Okay, so since I have only one node in my system, so there's each so if you see that 2 documents gets processed in parallel. Okay, so if at all if I configure, let's say 6 nodes and 2 threads in each of them, and then you would have 12 documents processed in parallel. Okay, so let me walk you through the solution. So you would first thing is so when you click on this process button, so I'm just showing you the configurations which are done on this button. Okay, so there's a script which is called initiate processing and a run activity. The run activity actually starts the processing in the background. So before that, let's see what's there in the script. Script is very simple, so nothing much. It's the same thing which was available in, and there's a little tweak which is done for the scripting. So it loops through all the buttons. There is a hidden button. So if you have gone through that solution of problem 1, so you know that there is a button which is hidden, and we just go through that, and then whichever checkbox is checked, all we do is we just initiate that GIF file which indicates that the processing is started, right? So you would click the button, so which you already know the button is configured to set an hidden field, and there's a run on visibility client. Okay, so if you I'm just opening this the button which is triggered. So all we are doing is here set the value to in progress, and based on the status there is a GIF file which would the same thing which is in problem 1. So it would get the when the status is in progress, it would the GIF file which shows the in progress would be visible, and the run on visibility client should be set to true, which means when as soon as I click on the button, this button gets clicked, it would set the hidden content as set to in progress. Based on that, run on visibility will run, and this image will start getting displayed. Okay, So that is done as part of your script. Now there's a small change which is done on the process button. So it would call an activity. So in this activity, what we are doing is we are looping through the documents list, and then we're checking if at all if they're selected. Then we're creating a page of a queue. So we have created a queue system queue document processing class, which is a queue class. So we're creating a page, setting the item ID, which is the document class plus the document ID. We are setting it to item ID, and then we are queuing it for an queue processor. So there is already a standard queue processor which is given by Pega. We are using the same thing. If at all, if we want to create our own dedicated queue processor, we can create our own. I'm just using the standard document queue for queue processor, and I'm giving an activity queue processor. There is no locking, so the locking is, if at all, if you are using based on the step page, if it is a work class, you can just use the PZINS key as the locking. So anyway, since we are using queue class as the step page, the page of queue class as a step page, so we don't need locking right now. We are just selected. As soon as this step is executed, it gets committed to your database snapshot, because we need the step page snapshot to be available, and then access group. We are using a different access group to process the each of the document. Okay, so you can check this help. I think you can go through the PDN to understand more about queue for processing. So which is the advanced version of agent which can run in multiple nodes, and especially you can run on multiple node. Not only run on multiple nodes, in each node you can have multiple threads to process the queue instance. Okay, and the other advantage is you can actually run them immediately. In agent, there is a delay of 30 seconds, right? The agent gets waked up every 30 seconds and starts processing it. But here in queue for processing, what happens is there is an option to the as soon as it gets queued, it gets processed immediately. That option could be configured on your queue processor. So let me open any queue processor which is already there. Let's take the standard one itself. Okay, so it's not available here. So let's go to the admin studio, queue processor. So this is the standard Pega out of the box standard processor. If you see here that as soon as it gets queued, it gets immediately starts the execution of that queue item, and then there are two threads running as part of each node. So if at all, if you have two background nodes which is configured, so you would have this particular queue processor running on both the background processing nodes, and your processing capability would be 4 documents at a time. So if two nodes, two threads in each of them, so 4 documents in parallel. I mean processing 4 documents in parallel. So we queued it. So once it gets queued, and once the execution of the queue item starts, this is the activity which gets executed. So activity is also part of the queue item. So this is very simple. So we are just getting the item ID, opening that document instance from the database, setting the status, and then saving it as part of the saving the document instance back to the database. In live scenario, it would be we would be having an external service which we have to call by passing the document ID, and this document, based on the status of that service, we would be setting the status here. But since this for simulation purpose, I've already hard coded it to complete always. And to simulate the wait, I've just used the wait shape for waiting for 3 seconds. So when we are actually using multi-node, once the document processing is completed, we have to push. If you see our solution, so once the document processing is completed in this node, there's a message which is pushed through your channel and which goes to your browser, right? This particular part is done through here. So we have created a channel called document processing, and we push the data which is part of this document processing page. So I'll just show you how to create this channel. So you can go to the user interface and then click on channels. So you can create a new one. So I'm just opening the existing one. So click on settings. So I've given the document channel name, just description used for processing the documents, the rule set, and the class. The class, I've used the data class here, and I've mentioned whenever you push the notification as part of your message, what property should be present, right? That's the PYD dot ID. The document ID should be part of your message is sent from your server to browser. Okay, so this is the we have created the channel. So now using this channel, whatever we are doing is we are pushing the message to this channel. Okay, so there should be something which is on your browser. There should be some component which is waiting for this message to come from the server to browser. So if you see here, there's a component which I've just marked it in a box. So this will be waiting for the message to come. Okay, so I'll be showing within Pega where it is actually exactly done. So you can actually go to the same section, status section in the data document class. So you click on this settings. So you would the action, go to the action. So there is a new action which is given by Pega and 8. I think 8.1 onwards. So on load. Okay, so it's in 7. I'm not sure about. Let me check that. So it is a event, onload event, where you can wait for a message which is coming on a certain channel. So we have selected document processing channel, and we have mentioned what is the filter criteria, right? So the reason for this is there are multiple documents, there are multiple rows in the browser, right? There is a status section for each of them. So multiple messages come from the server. How would the browser identify which message should I consider? So that's the filter criteria which you have given. We are saying that so the record's document ID should match with the message document ID. If once you get that message, that means the document processing is completed in your server. And once that message is received, so what we are doing is we are saying that refresh the section, which will refresh this section. So as part of this refresh section, so all we are trying to do is load document status. So we're using an existing data page which will take the ID and return the status. So in your processing document, so what we have done is we are saving the status as part of this activity. But so one thing which you have to observe is you're not doing any right now. The reason is queue processing is it's like similar to agent, which is it takes care of auto commit. Okay, so you don't have to do right now. So once the status, once the this queue instance is processed using this queue processing activity, it will automatically commit, and the status is published. And status based on the status, we will be displaying the status on the UI. So we are just pulling the status from the database and setting it to your clipboard, and then it would refresh your section. So that is that is what this onload would do. Okay, so it would wait for that message to come. So if you see this, you can just imagine this is the status section, which would wait for the messages which is coming from this channel. Whenever a message is pushed to this channel would push it back to your browser. The browser onload component would check if this particular row's document ID is equal to the document ID in that particular message. If yes, then it will refresh your section. So that means it will refresh your section by calling an activity which would go to your same node. It will refresh. It will get the output from the database, and it will refresh your section. So with this, we would be achieving the parallelism using multi-node multi-node to process the documents, and the time taken to process the document is less compared to the sequential processing. So just a quick demo, which I've already shown you guys. So let's say if I've selected 4, all 4 will be processing of all the 4 will start in parallel, but 2 of them gets processed one after another. So based on the number of nodes which is available, so it might be quicker. The more the number of nodes, the quicker the document gets processed. So with this, we have solved the problem of interactive UI as well as how to run some of the processing in parallel using queue processors, and then how to use push notifications on your browser, push notifications using this scenario. Okay. So if you like this video, please feel free to like it. If you feel that there is any improvement which is required, feel free to add a comment. And if you want to stay tuned for more problems and solutions or more how to do within Pega and so on, subscribe for this channel to get the latest, so to be the first to learn things. Thank you.